Hi everyone, Mr. Mark. For today's video, I want to show you how to calculate the surface area of a cylinder. First, we're going to look at the formula for the surface area of a cylinder. Then I'll go through a few examples of some different types. So, to start with, the surface area of a cylinder is made up of two circles and basically one rectangle. So, the tube part itself here, if you unwrap it, it becomes a rectangle with the length of the actual height and the width of the circumference of that circle. So this is where the formula is derived from. 2 times pi times radius squared, which is 2 essentially. So this is the formula for the area of a circle, pi times radius squared. But we have 2 of those. Okay, so 1 at the top and obviously 1 at the bottom. And then 2 times pi times r times height. That gives us, if h is the length of that rectangle, the width along here is the circumference of the circle at either end, right? So that is pi times diameter, or 2 times pi times radius. And the reason they stick with usually the 2 times pi times r is because you're already using that radius in the formula as well. So you're just sticking to that same value. All right, let's look at 2 examples here where, sorry, I got 3 examples actually, where we've given a cylinder with a height, even though it's on its side, and a radius for the circle on the end. So how would that look as a net if I drew that? Basically, like we said, you've got 2 circles, okay, and a rectangular shape that makes up that tube. So the radius of each circle is 5 centimeters. So we're going to work out the area of 2 circles. And the height of this cylinder is 10 centimeters. And the width of it is 2 times pi times the radius, or 2 times pi times, in this case, 5. Oops. Try and get rid of that. There, that's better. 2 times pi times 5, or pi times 10. So the surface area calculation. So to basically work it out, I'm going to substitute those values back into the formula up here. Okay, so the surface area, or the total surface area of that cylinder, is 2 times pi times radius squared. Remember, that's the 2 circular ends, plus I'm doing 2 times pi times radius times height, and that's the area of the rectangle here, or the actual tube section itself. Now I'm just going to substitute the values from the net or the diagram into this formula. So it becomes 2 times pi times the radius, which is 5 squared, keep that in brackets, plus 2 times pi times radius again, which is 5 times 10. Again, you can bracket that off just to show that we're, you don't have to bracket that off when you put it in the calculator, but just to basically show that, you know, this first half part, this first half of the formula is the area of the 2 circles, and this part of the formula, second half, is the area of that rectangle. So if I threw all that on my calculator, which I'll do now, in fact actually let's use that one. So bracket 2 times pi times 5 squared. Oh, sorry, press the wrong 10. 2 times 5. Sorry, try that again. 2 times pi times 5 squared, close bracket, plus open bracket 2 times pi times the radius 5 times 10, close bracket, gives me a surface area of 150 pi. Now that's the exact value, and it'll probably say in the textbook round it to 2 decimal places. So to convert an exact value on your calculator, look for this S to D button here. Press that, converts it to me. So saying the area is approximately 471 let's go to 2 decimal places, 0.24. So So 471.24. In this case, the units are centimeters, and because we're talking about area, centimeters squared. So that's how you calculate the surface area of a cylinder. Now, in fact, I won't go through this second example too much, except for to say, notice that the 12 they give you here is actually the diameter of that circle at the top. So remember, we're using the radius, which is from the halfway point or the middle of the circle to any point on the edge, which is actually half of the diameter. So if they're giving you the diameter of 12, then the radius will be equal to half that, in this case 6. Okay, so again, very similar to the first example I went through up here. You're just substituting the radius and the height into that formula. Okay, now a little bit trickier if you have a half cylinder. You can actually see that it's actually made up of half circle at the front, flat top section, the curved section underneath, and you can't see it here at the moment, but if I sort of draw it in, you've got that half circle again at the back. Okay, so if I was to draw that, you can actually see that it's got two rectangles. It's got the rectangle here with the two half circles at either end, okay, plus the curved rectangular section that goes around the bottom there, okay? So the in this case, they're giving us, again, the diameter of 3.8. So the radius that we want to use is half of that. Half of 3.8 is 1.9. So we're going to use a radius of 1.9, which is from there to there. And we're also going to use the length here of 6.2 centimeters, which is also 6.2 here centimeters. And the width of that rectangle will be 3.8 centimeters. So I'm actually working out, I guess, three or well, if I look at 4 different parts, I've got 2 half circles, so 2 shapes, a rectangle and another rectangle. So I'm going to then work out the area of all those shapes using a slight variation of the formula. So the total surface area of this half cylinder is the area of the 2 half circles, which actually makes up a full circle. So there's a couple of ways you could do it, but to keep it simple, you could just work out the area of 1 full circle. So you've got 1 circle there, plus the area of this rectangle here, and plus the area of that second rectangle, which we just spoke about as being that curved section, okay? So if I was to work out the area of a circle, I'm using the formula pi times radius squared. If I'm working out the area of a rectangle, I'm just using, and I've got the length and the width given to me, I'm just using length times width. And I'm working out the area of that final rectangle. This is a little bit trickier because we've only got the length here. The width will be the circumference of half a circle. That length is the same as that length there, which is the circumference of half a circle. Okay, so the formula that we would actually use in this case would be half times 2 times pi times radius times by the height, okay, which in this case is 6.2, okay? Let's just keep it at that. Obviously, you can simplify this by half times 2 is 1, so they will sort of cancel each other out anyway, but I'm just showing you that for the sake of this. That's where it will come from. So substituting values back into this formula, it becomes pi times 1.9 squared. Remember, 1.9 is our radius, plus length times width of that flat top section there, which is 6.2 times the diameter, 3.8. Then we're adding a half times 2 times pi times by the radius, which is 1.9 again, times by the height, which is 6.2. Looks pretty complicated, but if you break it down into all those individual shapes and understand where it comes from, then it becomes a little bit more manageable. So then that will just go straight into our calculator again. let's start with an open bracket, pi times 1.9 squared, close bracket, that's the 2 half circles on either end, which make a full circle, plus the area of the flat rectangular shape at the top, which is length times width, or 6.2 times 3.8. And then we're adding, so close bracket, open bracket, then we're adding the area of those two, the area of that curved section. So 1/2, or half, times 2 times pi times 1.9 times the radius times by the height, which is 6.2, sorry. Close bracket equals, and again, to 2 decimal places, in this case, 71.91. And again, it's given in centimeters, and because of the area, it's squared. So there you go. That's how you would work out the total surface area of a cylinder. And a half cylinder, yes, there is a bit of a formula for cylinders that you can use, but I think, yeah, understanding each section and what it means, so that when you get a question like this, you've got half a cylinder, being able to basically work out the area of the individual components, or the individual shapes that make up that half cylinder is really important. Anyway, thanks for watching and hope that helps.